Good morning, everyone. My name is Swee Hin, a mechanical engineering student from UniMAP, and today I will be presenting my reflection on the Advancetech manufacturing case study for our management for engineers course. So as you can see, the team members are built up from 5 different or students from different races. First is Yusron, and second will be Fitri, third will be me, fourth will be Afika, and Swan will be Raj. So to start, let's look at the case study overview first. The main challenge we diagnosed was a series of cross-functional operational bottlenecks during the development of a lightweight automotive braking component. The core issue was that key stakeholders, specifically design engineer, production and procurement, and also the quality assurance, were operating in isolated silos, which is working alone. This departmental misalignment lead to severe impacts, including production scheduling delay, increased costs, and compromise overall team efficiency. Our objective was to apply project management framework to uncover these root cause and propose structural solution. My personal contribution to this project focused on diagnosing operational friction through problem and conflicting requirement analysis. So moving on to the root cause analysis, we utilize the 6M framework, which is we design a fishbone diagram, which you can see mapped out on the fishbone diagram. We categorize the issue into two main areas, operational friction and strategic misalignment. Under operational friction, we identify method as a problem area. Unclear task responsibility and siloed information flow lead to duplicated tasks and uncoordinated design changes. For manpower, we found that difference in communication styles and technical backgrounds caused severe misunderstanding between the engineers and the factory floor staff. And on the strategy sides, management. KPIs were directly conflicting. For an example, procurement prioritized minimizing costs while the production prioritized speed, forcing teams to essentially work against each other. And finally, looking at materials, we note that uncoordinated supply chain deliveries combined with the push for cheaper substandard components disrupted the production flow and threatened the final product quality. And to resolve these operational challenges, we applied three project management tools. First, RACI matrix, which is responsibility, approve, and what is it? Consulted and informated. We developed these to eliminate overlapping authorities by explicitly define who is responsible, accountable, consulted, and informed. We successfully prevented operational ambiguity. So move on. Second, risk matrix. We utilize this tool to map the probability and severe impact of departmental conflicts. As shown in the visual matrix, this was particularly vital to highlighting the high risk danger of bypassing safety protocols just for cost reduction. And third, a work breakdown structure, which is WBS and Gantt charts. We integrated these to fix downstream delays. This ensured that production does not commence until the design engineering fully finalized and freeze the component blueprints. Next, I want to discuss the impact of team diversity, starting with the case study context and versus the student group. I will start with the case study first. The danger of silos, which is working alone, become obvious. When the departments only care about their own goal, like procurement minimizing costs, and while the production maximizing the speed, the whole project suffers. By mixing technical skills, we ensure our decisions are smart and balanced. The result is that every new design is checked for safety, cost, and manufacturability. So we mirror this collaborative approach in our own student group. Our group of 5 members features different cultural background, gender, and ways of thinking. And just like the departments in the case study, we knew working alone causes tunnel vision. So we actively avoid silos, which is working alone. By practicing active listening to different viewpoints, we spotted errors early. Ultimately, this diversity helps us balance our final report, ensuring we cover all technical, financial, and also the ethical angles comprehensively. So this leads to crucial lessons in professional ethics and sustainability. From an engineering ethics standpoint, I learned from this case study that public safety must always defeat the push for cheaper material. We also recognize the importance of human sustainability. Rushing production inevitably cause the machine failure and worker burnout. Applying this to our own group value, we learned that importance of accountability, fair workload distribution, and respectful communication to meet our deadlines. To conclude, looking at the future teamwork improvement, a major area I plan to improve is better conflict resolution and early planning. My immediate action plan is to stop using messy, unstructured group chats for making big decisions. And moving forward, in future projects, I will apply these lessons by acting as an inclusive leader, but I'm not the leader of this case study yet, so maybe I'm planning to be one. And setting up a RACI metric first on the day one to assign clear roles and responsibility. Thank you for your time and attention. That's all for me.